This video is about solving logarithmic equations with different bases. But before we get into it, we need to learn about the change of base formula. So here's the change of base formula. If we have log A base B, if we change this, it will equal to log this A, and I can choose any base I want. Let's say I choose a base C, divided by log of this base. And whatever base I choose here, that must be the same base here. And this is my change of base formula. Okay? Alright, so let's move into this question here. This question says log x base 2 plus log x base 4 plus log x base 16 equals 7. So I can get a base 2 from 4 and I can get a base 2 from 16. And so I want to keep this base. So I'm going to change this base and I'm going to change this base here. Alright? So I'm going to rewrite this part. So it is log x base 2 plus, in changing the base, it's going to be log x, which is this part here, base 2, because I want it to be this base, so it is base 2, divided by log of this number now, which is 4, and I'm going to keep the same base here, which is 2, plus, I'm changing this as well, so it is log x base 2 divided by log of 16 base 2 equals 7. Okay? Alright. So log x base 2 plus log x base 2 divided. Now, what is log 4 base 2? Log 4 base 2 is 2. How do we know that? What base must this number, what exponent must this number be raised to in order to get 4? So any number it must raise to get this, that will be the number down here. So it is 2 to the 2 equals 4. So that is why we know this should be a 2. Plus log x base 2 divided, what is log 16 base 2? Now 2 raised to what exponent will give you 16? It's 2 to the 4. And so this should be 4 right here. Equals 7. Okay? Now I want to get rid of these denominator here. So I'm going to multiply everything by the largest denominator, which is 4. So I multiply this by 4. I multiply this part here by 4. Multiply this by 4. And I multiply this one here by 4. Okay? So what we would have in this case is 4. Let's take it up. It is 4 log x base 2 plus 2 into itself goes 1, 2 into 4 goes 2. So I would have 2 log x base 2. So this is 2 log x base 2. This 4 will take out that, plus log x base 2 equals 7 times 4, 28. Okay? Alright. So let's make some room here. Alright. Now look at it. This is 4 log x base 2 plus 2 log x base 2 plus I could put a 1 here, so that is 1 log x base 2 equals 28. So how many log x base 2 do we have in all? So 4 log x base 2 plus 2 more log x base 2, that is 6 log x base 2, plus 1 more log x base 2, that is 7 log x base 2. So this is 7 log x base 2 equals 28. And then I divide this thing by 7, and I divide that part by 7. So the 7 here cancel. So I have log x base 2 equals 28 divided by 7. That is 4. Okay? Now I'm going to apply my exponent law of logarithm here. Okay? The exponent law states that the argument will be equal to this base raised to this exponent. So it means that x, which is the argument, is equal to this base, which is 2, raised to this exponent, which is 4. Alright? So 2 to the 4, that is 16. So x equals 16. Alright? And that is our first example there. Alright? Let's look at example 2. Example 2, it says log 10 base x plus log 10 base x squared equals 6. I can get a base x from x squared. And so I'm going to keep this base. I'm going to change this one. So it would be log 10 base x plus log 10, which is this part. I'm going to keep this base here, base x, divided by log of this now, which is x squared, with the same base here, equals 6. Okay? So log 10 base x plus log 10 base x, which is the numerator part here, divided by, what is log x squared base x? Now, what exponent must I raise x to in order to get x squared? I must raise x to a 2 to get x squared, so it means that this part here will be 2. Remember, whatever exponent you must raise this base to in order to get the value of this, that's what this denominator will be, okay? And that equals to 6, alright? Now, I want to get rid of this 2 from the denominator, so I can go ahead and multiply everything by 2. Alright? And then this 2 will take that out. So what we would have in this case is 2 log 10 base x plus log 10 base x equals 6 times 2, that is 12. Okay? Now look, this is the same as saying 1 log 10 base x. And so we have 2 log 10 base x plus 1 log 10 base x, that is 3 log 10 base x equals 12. And I can divide this thing by 3, and I divide that by 3. So that cancels. Let's take it up here. So log 10 base x is equal to 12 divided by 3, and that is 4. Okay? Again, I'm going to use my exponent law of logarithm here. So it is the argument, which is 10, equals this base raised to this exponent. So it would be x raised to the 4. So to find x, I'm going to take the 4th root. So it is the 4th root of 10 equals the 4th root of x to the 4. Okay? So the 4th root is going to remove the 4 here. So it is just the 4th root of 10 equals x. And this is your exact value. Now, if you want a decimal answer, that's an approximation. So let's find what is this thing here. As an approximation, it would be, here we go. So we hit 4, and then math, and we scroll down to number 5, and then we hit our 10. So there we get 1.78. That is the approximate value of x. Okay? Alright. Let's look at one final example just for practice. Alright, so this one here we have log 2 base 7 plus log x base 49 equals log root 3 base 17. Now, I can get a base 7 from 49, and I can get it from 1/7. Okay? So I'm going to keep this base. I'm going to change this, and I'm going to change this as well. Okay? So this would be log 2 base 7 plus log x, which is this part, base 7, divided by log 49 base 7, and that will equal to log root 3 base 7 divided by log 1/3, not 1/3, 1/7 base 7 as well. Okay? Alright, so log 2 base 7 plus log x base 7 divided, what must I raise this 7? What exponent must I raise this 7 to in order to get 49? I must raise it to 2, because 7 squared is 49. So it means that I would have a 2 here. Okay? Equals my log root 3 base 7 divided by, what exponent must I raise this 7 to in order to get 1/7? I must raise it to -1. Because 7 raised to the -1 is the same as 1/7. Okay? Alright. So this part is log 2 base 7 plus, I want to get rid of this thing here. So let's just rewrite it. Plus log x base 7 equals log root 3 base 7 over -1. Okay. I want to get rid of the, and there should be a 2 here. I want to get rid of the 2 from the denominator here. So I'm going to multiply everything by 2. So I multiply this by 2, and all the terms by 2. Alright, this 2 will take out that 2 there. So let's take it up a little bit. Let's take it up here. Alright, so what we have now is 2 log 2 base 7 plus log x base 7 equals 2 divided by negative 1. That is negative 2 log root 3 base 7. Alright, now I'm going to take this as an exponent here, and I'm going to take this negative 2 as an exponent here. So this would give me log 2 raised to the 2 base 7 plus log x base 7 equals log root 3, and I'm going to write it like this, log root 3, and I'm going to raise that now to the negative 2 base 7. Okay, so 2 times 2, that is 4, so this is log 4 base 7 plus log x base 7 equals, this is a square, so the square root would remove the square root here, but for those who can't see it, let me write it like this, log root 3 square raised to the negative 1. This is the same as saying that base 7. Okay, alright, so let's finish it up here now. Okay, so this now we're going to use the product law of logarithm. Okay, so once the coefficients are the same and the bases are the same and you're adding, you're going to multiply the arguments. Remember, this is the argument here, this is the argument here. So this would just be log of 4, which is this argument, times x, which is that argument, base 7, equals log of, this square is going to remove the square root here, so it would be log 3 raised to the negative 1 there, base 7. Okay, so this is just log 4 times x, that is 4x base 7, equals log 3 to the negative 1 base 7. So the fact that the bases are the same, we're going to drop the log and just equate the arguments. We're going to equate just the arguments. Okay, so this is going to be 4x equals 3 to the negative 1. But remember that 3 to the negative 1 is the same thing as 1 upon 3. That's 1/3. So this is 4x equals 1/3. Then we divide both sides by 4. So x equals, and I can write this 4 as 4 over 1. Now if you go back to your knowledge of dividing fractions, you keep the first, change the sign, and then flip the second. So it is keep, change, flip. So I keep my 1/3, I change my sign to multiply, and then I flip my 4 over 1, and that becomes 1 over 4. Okay, so x equals 1 times 1 is 1 over 3 times 4, that is 12. So x equals 1/12. Okay, have a fantastic day.